Hey, good morning, everyone. Thank you for joining us today for another session on OpenShift Coffee Break. My name is Jafar, and today I have the pleasure of hosting Henrik Rexed. I hope I pronounced it correctly. So,
Hi.
thank you for joining us today. So, Henrik, would you please tell us a bit more about you and what we are going to be talking about today?
Sure. So first of all, it's a pleasure to be here. So for a coffee break, I took I bring some tea. I didn't know which type of beverage I was allowed to drink today. So I have the tea and I have the coffee. So in case I will be able to switch to one or the other beverage. All right. Otherwise, my name is Henrik Rexed. I am a cloud native advocate at Dynatrace. My main focus at Dynatrace is everything related to cloud native technology, of course, on observability. So my focus is on observability on Kubernetes, OpenShift, NES stories, methodologies as well. So here I'm very honored to be here and present how Dynatrace can save your life from a broken cluster. And for this, to just some tease about what I'm going to present, I have picked two real production outage that happened for real big brand of the industry, and we'll explain how that happened and how we can resolve it, and of course how the Dynatrace can help you there.
All right, thank you so much, Henrik. Yeah, I really appreciate the fact that it's going to be, I would say, pragmatic, because we're going to be talking about real life situations and understand how those monitoring stacks that you provide can help address those issues. So yeah, okay. So without further ado, um, maybe would you like to tell us? So yeah, maybe just to set the context. So I've been working on Kubernetes and OpenShift for many years, for about 6 years now, and I have been in those situations where you're trying to understand what the hell is going on or what the heck is going on, and because those technologies are using so many layers, sometimes it can get really hard to go back to the root cause and really understand if this is coming from the cluster, if this is coming from networking, from storage, from an application. Is this a performance issue? Is this like a service that is completely down, etc.? And so, yeah, I hope that by the end of the session, we can better understand how to, yeah, troubleshoot those kind of issues and better investigate, I would say, the problems that we face when we are working with a Kubernetes cluster or OpenShift, for instance. So okay, let's go ahead and
All right, let's do that. So I already started introduce myself, so I'm not gonna go again on this one. But before, just a small tease. Prior to work at Dynatrace, I've been working as a performance engineer. I'm trying to optimize and understand issues. That was my main goal previously. I'm still with Observability, of course, because performance engineer is still in my heart and I love performance engineering activities, I am producing some content for a podcast and YouTube channel called Perf Bytes. So if you want to learn about performance engineering aspects, check out Perf Bytes. And otherwise, 1 year and a half ago, I started another YouTube channel called Is It Observable? Yeah, so you have in the name, you can hear observable. So it's about observability. So I'm producing content about how to getting started in using FlintD, FlintBit, what is a service mesh, a couple of things about always related to observability in general. So check it out. This channel is quite young and it deserves feedback to improve the content. So what are we going to learn on the next couple of minutes or almost an hour? So a couple of things. So the two production issues that I have selected today comes from a well-known brand of the industry, but they are all related to service mesh. So service mesh is not bad. In the opposite, it's great. But there are a few things that you have to consider when you start working with service mesh. So we'll see those problems in details. We'll see how we could avoid those problems if we were using Dynatrace. It will be an excuse for me to share the latest and greatest news about the Dynatrace product. And we'll see that Dynatrace has an AI engine called Davis, and we'll see how Davis can detect those problems based on Kubernetes events. All right, so let's start. Because I don't know how much knowledge you know about service mesh, I will have to do a small introduction reminding what is a service mesh, what's the value, and then we will quickly jump into the core topic of today. So, like I said, in a Kubernetes environment or in OpenShift, to be able to expose your services out of the cluster, you have different way of doing it. And one way of doing it is using a service type load balancer, which is not the best, of course, but you also have the options to utilize a service mesh that will allow you to handle the incoming traffic and manage the traffic within your cluster. So that's one of the things. So it's manage the communication of your microservices. But when you start building microservices architecture, first you need to provide features. You focused on building those features in the code, but your microservice is going to interact with other services in your cluster. So there are a couple of things that we have to handle. So either you code it or not, but there is the retry logic. So the retry logic is very simple. I have service A, service B. I try to reach out to service B is not responding. I need to do a couple of retry, and after a number of retry, I will throw an error. The second use case, which is we need for also for microservices, is authentications. So if I need to authenticate with a service B in a specific way, I probably have to need to code that way, that piece in my code. So I will have to handle that. And not last, but there is also a crucial component of the security is the SSL, the certificates. So I may not code it. I will probably ask someone to generate a certificate. But again, it's great to have a certificate, but we have to rotate it to make sure that it's secure in a long term. Of course, there are the other features that are important. Like, of course, we need to get some observability out of our microservices. If we do blue-green deployment, we probably want to be able to do traffic split and many other type of features that are related to microservices communications. So the main advantage of service mesh is that it's going to handle those features without any extra line of code. Basically, you build our application container that has only the feature that we need, and all the rest will be managed by a sidecar proxy that will manage those different features, observability, security, authentication, and so on, in that sidecar proxy. So service mesh is handle the communication by adding new CRDs, and those CRDs will help us to configure the service mesh itself and inject the right proxy rules in our different pods. In fact,
yeah, Henrik, sorry, just maybe for the people who are not really familiar with what CRDs are.
CRDs is custom resource definitions. It's a way of customizing and adding new objects in Kubernetes.
Yep. All right.
And then what I was saying is that if you want the way you want to configure your different proxies, of course you're not going to touch every pod's single instance of each pod and I'm going to add a container, an extra container there. No, it doesn't work like this. A service mesh has a control plane, and so it's a master, I would say, component of the service mesh where you're going to interact with the control plane, defining I want to do traffic splits, I want to do virtual services, I want to do SSL. So you configure everything from the control plane, and then the control plane, when you deploy a new pod or new workload in your cluster, the control plane will inject automatically the proxy in our pods, which is fantastic. Which means I don't have to decode anything. The right feature that I need will be injected automatically on our workload. All right, so now you know most of the details which is required to follow the story. So once upon a time, a big brand booking platform that you probably have heard and probably you have used it for your vacations or even for business trips had a major production outage. And what was the issue? The old nodes of the cluster was fully saturated. So the ends the working day, they go back to home, and just before getting back home, everything was perfect, and they just went back on the next day. Everything was fully crushed. So they discovered that on the next morning that they were facing to an abnormal number of pods in the cluster. In a very like more than 500 plus pods were added in the cluster, and they were doing nothing. So they were naming those pods the zombie pods. So pods that were staying running in the cluster doing nothing but just eating our resources. So what was the initial reason for that behavior? So first, this company, they are trying to provide recommendation in the websites, and so they do some analytics through a recommendation job. So they have some cron jobs running continuously in our production environment that will collect some behaviors and provide the right recommendations. And they were doing that since many years. And just before the incident, they just deployed a fresh new service mesh. So all the pods that we expect from a cron job are started, they are running, but instead of being deleted after the job is ended, they will still be there, still running. So as a consequence, if we run a job and we keep adding pods and pods and pods, we allocate the resources. At the end, our nodes didn't have any memory and CPU left, and it was very hard to operate. And even more than that, other workload had difficult to be scheduled, so it will impacting more than just that small namespace or that small applications. So let's have a look at the cron jobs. I don't know how much you know about it, but cron jobs allow you to schedule a job in your cluster. And the main definition of the objects in Kubernetes is very simple. You define a template with the container that will hold your job to that will basically do the batch that you have designed. And the idea is that how it's been designed, it's scheduled. So Kubernetes launched the pod, it runs. And once the pod has been ended, then, of course, the pod has been deleted and the memory is released. The problem is that when you have a sidecar proxy, your job ends, but in the pod, you have two containers now. So you have one container that has ended his task, but you have a second container, which is a proxy, and the proxy is a thread. So at the end, the thread never ends. So even if our batch has ended, the proxy is still running. So our pod is not deleted by Kubernetes. So at the end, if we have injected for obvious reasons and because we need it, the sidecar proxy, in our case, our pod are never been deleted and we're facing two major problems. So how can we resolve this in a Kubernetes world? Well, let's see it. So first solution, very simple. We can add few settings. First, active deadline seconds in the definition of a job. It will just it won't save we won't save us for this problem, but at least it will limit the impact. The second one is concurrency policy replace. If you define this, Kubernetes, instead of adding a new pod, it will replace the existing one. So at the end, in Max, you will have one pod running for that given job or more if you have parallel jobs allowed. But again, it's gonna be less impact than having thousands of pods being scheduled in the cluster. The other big recommendation, of course, if you want to limit the impact, if you put resource quota in the namespace where your jobs are running, then you control. At least the scheduler will block and you won't be able to add more pods in that namespace. So, all right. So that's the really simple configuration aspect. Now, how can we basically resolve this? Because at the end, we need to force the proxy to end. So first solution, which is not the acceptable one, but let's have a look at it. The first solution is using a file. So I have my app running, and when my app is ending, I will write something in the text file or whatever I want, and the proxy will look at that file quite in a very regular way. And if there is something interesting in the file, he will basically stop the jobs. All right, so that seems very doable. But again, if I'm reusing Istio, it means I will have to rewrite the envoy code, and I don't want to go in that direction for sure. So what I would do is taking the solution 2, which is perfect because in fact, if I look at it, all the service mesh of the industry, Istio, Linkerd, and the others, they thought about that problem. They have an endpoint in their in their proxy where you could basically send an HTTP post request to it, and it will kill the current proxy. So at the end, my app is running. Once I have ended my batch, I send an HTTP post locally to the same in the pod. To depending on, of course, the service mesh, you will have different endpoints to interact with, and this will delete the container. And boom, problem resolved. Okay, so now we thought out how we can resolve it, but how can Dynatrace can help you here? A couple of things. So first, Dynatrace, as you probably know, we are an observability platform. In the cloud and EV space, and especially in Kubernetes and OpenShift, we have an operator that we will deploy in the cluster, and that will allow us to collect the various pillars of the observability. So the logs, of course, Kubernetes events, which is a rich source of information, metrics, traces, events, and way more. Also continuous profiling if you want. What is the value of that operator? So a couple of things. In operator, you can either deploy it from a UI, you can deploy it from Helm charts. There's plenty of different ways of deploying it. We need to have the visibility of the various objects of the cluster because we have a couple of different components that will be deployed. So the first thing that we will deploy is we will create an admission controller rule. So then every time there's a pod that has been scheduled, then we will be able to inject the right code module that will instrument your code. The other thing that we can do, in fact, we are quite flexible. We can deploy it with different observability way of doing things. We have the full stack where we will instrument your code, and we will also look at your nodes. We have just the app only, where we're just gonna instrument your pod, and that's it. So it's pretty flexible. But at the end, we have still a component called the active gate, and this active gate is a component that will basically interact with the Kubernetes API to get the health of the nodes, the workload, the namespace, and more. So this component is crucial, and we'll see there's plenty of features related to that active gate component. Dynatrace is providing out-of-the-box alerting for OpenShift and Kubernetes. So if you look at a cluster is like an onion. There's different layers. So you have the user sitting out of the cluster. You have the cluster itself. You have the nodes, namespace, and within the namespace, you will have some workload that will have on pods, and pod will have containers. And we have built predefined alerting that helps you to keep track on what's going on really on the cluster. So first, if you're outside the cluster, it means you're a user. We want to pay attention to the response times and the failure rates, because if there is something like memory problems or heavy throttlings, then the response time will be impacted. So our AI engine called Davis will automatically look at those components. So if the user is impacted in response times or failure rates, then boom, it starts and try to figure out where is the actual root cause. Then if you look at the cluster, I want to, of course, want to make sure that the cluster is up and running, that I don't have any expected any CPU saturation or memory saturations. Same thing at the node level. Node can have different status. So I want to make sure that all my nodes are in a ready state, that I have no CPU or memory saturations. And if I go to each of the layers, we will add those alerting. So we will be you'll be aware of what's going on. And same thing for the workload, even better. If you have some workload as in pending states, it's a sign that there's a memory problems or a configuration issue. If you have your pods in not ready, or they are restarting, doing a crash loop back off error, sometimes you will want to be alerted quite fast. So those will be handled automatically. All right. I get your point. I know that you want more. That is not enough to operate your cluster, but don't worry. We know that there's a couple of things coming in the next couple of months. So be patient, and we will give you more alerting out of the box. So that's just a start, and we will have more and more things. We will cover most of the components of the cluster.
And so just a quick question, Henrik. Is there a way to define your own metrics, not metrics, but your own alerts based on some existing metrics?
Of course, yeah. That we there is Dynatrace is a huge platform to be honest. Today, you can do tons of things, but we have lots of customers that operates tons of clusters, and they don't want to go and build their metric expression and then add the thresholds because it will take a lot of time. But of course, if you know exactly the metrics, you have the ability to do your custom anomaly detections. We call it alerting, but it's for us it's anomaly detections, and those will be also taken into account. What is great as well to just add, and that's pretty much what I was going to say on that slide, is that when you operate clusters in Dynatrace, you probably have more than one cluster. Obviously, probably have 10 to 20 to 50 or 60 or 100 of clusters that you have to operate. Usually, what happens is that I have some alerting that is predefined and globally for Dynatrace, but it happens that some clusters are, let's say, this is a cluster managing our AI discovery or analytics, and I have different type of thresholds. I have different type of requirements. So I want to change those alerting just for that cluster. And you have the options to customize the alerting at the cluster level, but also at the namespace level. Let's say I have a team that manages a specific application, and they are completely they have huge requirements and they don't accept the predefined alerting. They are free to configure as well the alerting on based on their requirements. So it's pretty flexible. So we have a different level of configuring those alerts. So either from the custom out of the box alerting, and yeah, like mentioned, or through metric expression where you extract the metrics and you define it. You can also extract something from the logs, convert it into event, and that event could be also an alert as well. So there's plenty. It's very flexible to create alerting in Dynatrace. One thing that we did, this out of the box alerting was something that we provided to our users. I think now they have it on the hands last week or something like this. We also created predefined dashboards. When you operate Kubernetes clusters, we also provide out of the box dashboarding. Of course, you can create your own dashboards. You not have to be stick to those dashboards, but those dashboards are designed to give you pretty much a cluster overview, the workload overview, the namespace. And what is great is we have increased the user experience in the way where from a dashboard you can easily jump to the right screens, or from the screens you can go back to the right dashboards with the right filter. So it's lot of small improvement, but it helps you specifically when you have to troubleshoot. So enough of talking. Let's go to something live and show you the screens. So for this, I have prepared an environment. I have deployed a couple of things. That's of course this is just a suggestion. So here's the GitHub repo related to this environment. So have two namespace with two applications. One is the OpenTelemetry demo application provided by the OpenTelemetry community. So it's fully instrumented with OpenTelemetry. I'm using the OpenTelemetry operator to be able to deploy OpenTelemetry collectors to forward the traces back to Dynatrace and the metrics to Dynatrace. I have Linkerd here. I decided today to use Linkerd for this specific this use case. Again, Istio will be the same, but again, it's just to highlight the usage of a source mesh and reproduce the pattern that I just explained. And by the way, this morning I almost killed my cluster, so I was trying to recover just before I was connected to Restream. All right, so let's see that in details. Where is my browser? But here is no. Where is it? Here it is. Okay, so here is first. Let's start everything from the dashboard perspective. One small note: when you're using OpenShift, the advantage that you would have compared to a traditional, let's say, a user that uses another flavor of Kubernetes is that OpenShift provides you details on the master nodes, lots of things that are very important, especially when you have to operate. So we have predefined dashboards for the control plane of the OpenShift cluster. We also have dashboard for etcd, but in my particular case, I want to show you the dashboard that we have for the cluster. So here in this cluster, I have two clusters deployed in this dev tenant cluster, I will first filter to only the one I'm interesting, so the one with OpenShift. And in that dashboard, I will be able first to see what are the running pods running in this environment. To easily jump to my cluster details, and from the cluster details page, I will be able to see the cluster view. So how many nodes do I have, the workload, the various events happening in the environment. And what is great is also, if from the node perspective, by the way, you can see here during this morning, when I connected, I saw that I was almost losing everything. So I was able to recover just before it was too late. But small note. So here, if I look at the nodes, I can see the status of them and how the usage of each node. And if you, in my case, I'm using cloud native full stack, so I have the node instrumented and the app instrumented. But then if I jump into the node perspective, I will be able to see all the details on what's going on, if in fact, in this particular cluster. For example, here we see that we have a spike here. You can see here in the CPU usage, CPU user, we have this spike here coming up, and I wonder what's happened. Or I can also do it on the CPU load. So here I simply have to select, for example, this to zoom in here in this area where we have this behavior, and I can select it, and you can see that we have, oh, it does. I think the time frame is not good enough. Let me take something more. Oh, okay. Or maybe I can do it here. Oh, now I need to zoom out. Okay. Let me go 2 hours. I'm surprised. Up. That's what we call a demo effect. So let me grab this piece here where we have those spikes in blues here. When you see the system load here, is quite often we have some spikes. So let me grab that CPU load and see. In here, what I'm going to do here is say I have some patterns that I see in the graph. I want to understand what is actually causing this. So I'm going to ask the AI engine Davis to analyze all the metrics that, oh, no correlation. All right, that's a bad example. So let's have a spike here. Let's do this. Traffic in. And here, Davis is analyzing all the processes that is actually available in this host, and he will correlate. And it says first, we have a process CPU usage. It's the load generator service. So we can see that it has already attached to the right process. So now I know, by just looking at this specific graph, that this behavior was related to one specific process. In our case, because we were running in a cluster, it's going to be a pod. So once I have the information, I can go back to the cluster and go to the right workload where I saw that pattern. So I will go to the namespace. And here in my case, I know that the namespace that was looking at is this one where we have this load generator service. And in fact, here I have limited the impact because if I didn't limit it, I would have probably 50 pods here running, but I have limited the impact. And this is the cron jobs that I explained that were basically consuming resources. And as you can see here at the moment, we have already 3 of those pods running and eating my resources. So that were basically this is how I recovered this morning to avoid losing my cluster as it is. And what is great here, you can see that also in this particular workload, we already have an alert that it says that the workload is not ready. And as you can see, there is also exclamation points on the top, and we have all those alerts that has going. So first I had some no pod ready. So you can see that all the various workload, we have a couple of informations. We also have some failure rate increase. So this is different. It means that something has impacted a user perspective. So here, Davis is trying to analyze and figure out who is responsible of that behavior. So as you can see, with all patterns, at least we are aware of. We have pending pods, or we have here the hipster shop namespace is also as a resource quota saturations. So I can easily go back to the right namespace and look at that problems in details. As you can see, I was not able to schedule the load generator services on this one. So depending on where you are, you can easily jump to a workload or to a service or to the pod. So here I'm on the workload screen. I can easily look at the services response times, or I can also look at the pod itself, jump into the pod screens, giving me the CPU, the throttling, all the different details, looking at the logs, the events of this particular container, particular pod, and so on. What is great is that we also have the notion of services. So here I can see the definition of that particular services. And if it's been instrumented here, we have a relation with the application fully instrumented by Dynatrace. And once it's been instrumented, I can see the traffic that has been happening on this particular pod. And yeah, I can even go further and say, oh, I want to look at let's say I want to look at, for this particular request / cart, I want to look up at the distributed traces. So here I will see all the traces that has been collected during that time frame. I will grab this one, for example, and I will see exactly all all the steps related to that specific transaction. So you can do tons of things from the infrastructure perspective to even going further to the application layer. All right, so now that was the first story. I'm looking at the time because I talk a lot, but so we have still time. All right, so the second story that I have.
So Henrik, yeah, if you don't mind, if we can just pause quickly there, because you've shown a couple of really interesting features that provide a lot of value when trying to troubleshoot those issues. So as most of people who work with Kubernetes know, there are already some community tools that go hand in hand with Kubernetes to do monitoring and to provide some kind of dashboards with those graphs and resource consumption, etc. Like Prometheus and Grafana, and the combination of those. But I think what you showed here is really something powerful, because the other type of tools or types of tools, they don't really provide the drill down capability where you say, okay, so I see there's a spike here, but let me drill down and really try to understand what's going on. It's going to give you an information. Okay, today at 10 a.m. there was a spike in CPU, but how do you correlate that to the actual workloads that have triggered that spike in CPU or spike in memory consumption? And yeah, I think this is, so it looks casual here because you are just clicking there, etc. But it's really, really a powerful, I would say, capability, and especially knowing that there's some analysis that happens in the background to say, okay, this is the normal behavior because you have trends, I guess, and the AI tools are like observing this is the normal behavior, nothing has happened, and now we can detect that there's a spike because there's a big shift compared to like the normal behavior. And I guess that's also where the AI magic happens, is because it's able to understand that abnormal behavior, and it's also able to correlate it to other things that happened elsewhere and say, okay, so this that you see here is basically caused by something that was down there. And it would take, I would say, a lot more of investigation to be able to get there if you are using traditional tools, I guess.
Yeah, I mean, that's true that I think alerting based on thresholds are great, but sometimes you want to also understand if you had a change of behavior, like you mentioned, and having a baseline approach where it detects changes over time, and if there is a change, and it will basically try to understand why we have this change. But moreover, here, I mean, it's a demo environment, so there's no it's my own tenant. But what here, if I click on, if I have a real alert impacting users. So maybe I have another one examples. I will check. I will have check. But when we have a problem impacting a user, what Dynatrace will do, we will try to estimate the number of user impacted by that problem. And also, if you're using cloud regions, you will see, okay, so it's only the user, so thousands of user out of whatever was impacted in specifically in the region of New York. So it will also help you to figure out who has been impacted, and it goes even beyond. So I think when you are troubleshooting, usually there is fire, there is pressure, so you need to be able to take decisions in time. And I think having the right toolings and the right information in your hands, then you can make the right decision. And also, I didn't mention, but we also have the ability to, once we have a problem that we have a pattern that we have detected and we understand and we control, then we can trigger a remediation. So we can reach out to Ansible and say, hey, do this. Because I reach out to that, I don't know, part saturations on the quote service, then do this because I have a specific playbook that I want to run, and that will be possible. So you can even think about auto remediation process fully triggered by the AI. So I think that is fantastic. So you can even recover in a faster way.
That's really awesome. And actually, that was one of my two questions that I wanted to ask for that section. So that's I would say the first one, and it's pretty amazing to be able to do that because, say for instance, you said that the pods are being spread on the node, and as we probably know, you have some IP allocation that happens on the pods, and that creates some files on down there in some system files for the containers, etc. And a simple troubleshooting to be able to get rid of that. Well, of course, you have to kill the pods, but you have also to remove those allocated IP addresses if it doesn't happen properly by the by the kubelet, etc. And so that's one example where having that Ansible, where you say, okay, so we have reached our limit on pod scheduling capacity, so there's this thing that we need to trigger to be able to remediate basically that issue. So that's really good, to be able to associate those. My other question was, so of course, as you said, the sooner you know what happened, the better you are, the more time you have, of course, to address the issue. And so my question was regarding like notifications, emailing, to what systems can you connect to send out basically, critical issue? Do you connect to things like Slack or any messaging or any, I guess, emailing systems?
Yeah, we have Slack integrations. We have we can send notifications in various way. We used to have. I mean, there was a couple of years back. People are less interested in this. We have this Davis component that was running on Alexa and Google Home and the others. So you will be able to say, "Hey, Alexa, give me the status of my environment," and then Alexa was doing this, and then, "Hey, Alexa, open the dashboards and show me the problems." So, I mean, it was nice. I don't think that people are really using it in real production, but
Showcase.
yeah, but it's a way that showcased that we are able to send notification to various systems, and then you can do different type of usage with those notifications.
All right. Okay. Cool. So yeah, thanks. So that was those were my questions I wanted to address for that section. So yeah, if you want, we can move to the next section if you wish.
Sure. So I'm just looking at the time. So we have 20 minutes. So I'm gonna try to be a bit faster on the second one. So the second horror story that I have is again the same company, all again with related to recommendations, but here is more on the UI. How we're gonna deploy, visualize the recommendation to the users. So here, the problem that happened is that these recommendation services rely on a backend services, and this backend services for weird reasons started to crash in the middle of the day. And when they start to do the troubleshooting and understand what's the problem, they discover that, oh, there is we have placed a CPU limit on a given workload, and that CPU limit has caused an OM kill. So what? This is weird. So let's have a look why this is really happened. So first, again, they're using a service mesh. So to manage the communication between the services. And this recommendation service has to reach out to another service called the ad services. When the problem occurred or happened, we can see. So I have extracted the graph showing the consumptions. So we can see that we had a spike of CPU usage, but at the same time we had an increase of memory usage as well. So how could that happen? In fact, a couple of things. The ad services is Java based. So Java based, it means garbage collector. So let's say that we are running into a usage of memory which is quite high, and to be able to release the memory, the Java app will naturally launch some garbage collector to clean up the actual memory used by the Java application. So here we are using a service mesh. So when we do the communication, the pod has to go through the sidecar proxy and the recommendation services, and the recommendation services will reach out to the ad services. But here, at that particular moment, the ad services were running into memory issues. So the garbage collector was trying to run, but there was a CPU limit. And as you may know, when you have CPU limits defined and you reach the limit, you will have some throttling. So if I run a garbage collector and I'm being throttled, it means that I'm not able to clean up the memory because I'm paused during my task. I try to clean up, I'm paused. I try to clean up, I'm paused. So the memory is never released. So what was actually happening is that the sidecar proxy that was sitting close to the Java application, it did not have any CPU limit. So when the request was coming in, even if the pod was suffering, the traffic will still send to the pod and send over and send over and send over until a moment where no way of cleaning up the memory. So what happened? Kubernetes we reached out to the memory limit, so Kubernetes is basically killing the container. So this is could happen.
The
And
infamous OM kill, I guess.
yeah, the very famous OM kill event. That's true. And the only way to avoid that situation is to define precise requests and limits to your sidecar containers. But as I explained at the beginning, you don't define that because it's been injected through the control plane. But the good news is that every service mesh has annotations that you can add in your workload definitions, where you can define the actual CPU and memory limits for the proxy. So in Istio, here is the annotations for the envoy, and then you have a linkerd has also specific annotations, and will be a way of controlling it. So which means if I define the right CPU limits in this particular case, then I would avoid having the situation where my proxy is basically causing the death of my container. So how can Dynatrace can help you? Similar, I almost showed you that at the beginning, is that we use Davis. And the Davis is our AI. We had it since a couple of years, and we started to add Kubernetes events in the machine learning or the algorithm that is taken by Davis. So everything related to throttling. So CPU throttling, as you know, if you are throttled, then your program has been paused, so you're not able to do actually the work. So usually it impacts also on our response times. The second thing is if you have OM kill or out of memory events, what would happen is that your pod is killed and you generate some failure because the pod is not responding anymore. So you will probably have some errors from another services. Same thing if you have evictions or if you have evictions, of course, that will be also an event. But there's also something which is very important. You can have an OM kill or you can have some throttling. So which means I have decided to change my definition of my workload. I've decided to reduce the allocated memory that I need to optimize a bit my nodes. I can do that, of course. But if suddenly my change has introduced throttling, or if my change has introduced OM kill, then Davis will pick it up and say, hey, so we have an OM kill. And by the way, someone has changed the workload. And this is, since the workload changed, we can see that the problem has appeared. So it's even give you where actually we have that behavior. Second thing that I mentioned, we also had these service screens. I showed it before. What we are on the way of doing, we are adding more and more things in those screens. We will have the response time, the failure rates, and more and more. What we want is from the moment you have a service mesh embedded in your application, so at the service level, so on the networking layer, you want to have some stats. So we will also provide lots of information related to your service mesh. So this will come soon, so stay tuned. If you're using service mesh, you will have lots of value provided by Dynatrace. So closely, very briefly, because I'm looking at the time and we want to have a Q&A, of course. Last thing I want to show you is that I have picked because I don't want to browse and forever to show you the problem. So here, this is an actual problem card. You can see that we have 16. It's again 16 users impacted. It's 90 affected service calls. So we have the details on which services is actually having the problem. And at the end here, we see that the root cause here is an OM kill. So it has detected that we have a failure rate increase in this particular case, and the failure rate increase was introduced by this OM kill. So at the end, by looking at the problem card provided by Davis, you know exactly, okay, so I have an impacted on my users, and those users were at the end impacted by it because probably the workload definition is different, and we have some more problems. So there are a lot of things that we provide through Davis. So with the exclamation point is basically all the problems that Davis detects, and then you can walk through the problems and look at the response time degradations or all the other problems related. But also here, there's something else that we have introduced, not related to our topic of today, but I just want to mention, if you was wondering what is the icon next to it, is we also do runtime application scans. So here, for example, we see that we have 8 vulnerabilities in our environment, so we can grow and look at all the containers that are running. So here it's not offline scanning, it's runtime scanning, and based on this we can figure out problems. So if you have any, for example, here we have smuggling HTTP, so we can see the problems and details, where it's been happening, if it's and look at the details on this. So we also cover the security aspects out of the troubleshooting. So if troubleshooting could be impacted by a security issue, you will be also aware through that module as well. All right, so I think that's it for this. So key takeaway, very briefly. So first, as you saw here, when you use service mesh, there are things that are introduced due to the fact that we're using sidecar containers. So sidecar containers are great. It provides sometimes lots of great features, but it could have also a side effect. So you just have to be aware of those. So very simple, define resource quotas on the namespace. I mean, that's, it's important, and it will save lots of disaster. Defined also limits on your sidecar containers is also crucial, because you see, if you don't do that, for some reason, the sidecar could introduce some problems. If you use cron jobs, again, try to make sure that if your service mesh will be injected, will inject the sidecar proxy. Make sure to create the right process to be able to actually stop the job and not keep it running forever. Otherwise, in terms of Kubernetes, of course, make sure to, if you don't use a system like Dynatrace, make sure to have the right alerting on the cluster, on the nodes, on the namespace, on the workload. Make sure to also consider events in Kubernetes, because events is a rich source of information to understand what is actually happening, and then you can drive your analysis in the right direction. And of course, if you don't have the right level of observability, try to ingest external metrics, because there is plenty of great solution out there providing a lot of value. Like, for example, Red Hat is doing a great project called Kepler to measure the resource consumptions of a cluster. If you want to also to keep track on how much mini joule your CPU is consuming in your cluster, or memory, use this, is great, and you will be able to even extend the observability with that type of data. Small thing again, so I have this Is It Observable channel covering different topics. If you want to see more about service mesh, I have a dedicated content about it, so check it out. Again, the channel is quite young, deserves to be, the content could be improved, but to improve I need feedback, so check it out and reach out to me to see if you have some recommendation for me. Small housekeeping rules, just for those who are not aware. We have a joint webinar between Dynatrace and Red Hat happening on the Tuesday on 29th, so next week. So check it out if you want to see automating the cloud native enterprise with Dynatrace and Red Hat. To register, I think there's one colleague of mine which is awesome, Christophe Renders. So I would definitely recommend to connect. He has always great stories. Couple of additional resources, of course. We have produced a lot of content about Kubernetes in general and OpenTelemetry and stuff like this. Check it out. It's available on the Dynatrace YouTube channel. So if you want to learn more and see more in the product in live actions, we have a series called Performance Clinic that has been renamed Observability Clinic. So check it out. There's a lot of content that maybe could be interesting for you guys. All right. Do you have any questions?
All right. Thank you so much, Henrik. That was really, really interesting. I've seen some couple features. I'm not sure I totally understand what it meant, so I'm rephrasing it to make sure that that's what you mentioned. So you said, for example, there's an issue with the OOM kill that happened after a change of a specific setting. For example, you decrease the memory setting in the YAML files, etc. And so, is my understanding correct that Davis is able to hold the definitions of the different YAMLs that have been used and compare those over time and correlate what works to what doesn't work and say, okay, so we had this YAML definition, it was working fine. Now we have a new YAML definition with this change in this field and it doesn't work. And it says, okay, this is maybe what introduced the error. Is that how it works, or did I?
So I don't know if we store all the settings, to be honest, over time. I don't have the details, but yes, the idea is that what we want is sometimes by making some workload change definitions, we don't measure the impact properly, and we can introduce throttling or OM kill, or even if I do, I mean, that's human mistake. I do a problem in the name of the image. Let's say instead of do version 1, I made version 12 because I did some typing mistake. And if we generating some crash loop backoff error due to that, then Davis will say, oh, and we'll look at the definition that we had previously, and we'll say, hey, maybe that's the issue. So the idea is going to say maybe the issue is related to this. So same thing for if we have heavily throttling impacting user. Here for the case, it will say, okay, so throttling is heavily, and in fact, we just saw that yesterday you changed your workload, so it may be related to the fact that you changed the limits of CPU, for example. And same thing for mkill. So if I change the memory limits, I may also be facing an out of memory situation. So it's still, I think it's still useful to be aware that our change has impacted somehow the behavior of services. So then we can basically do the right thing at the right faster than if we have to dig in all the metrics that we have.
Okay, that's really nice. So yeah, it's sort of what I understood, and just wanted to make sure that was it, because it's it's really nice to be able to compare data over time and provide that feedback, because otherwise we would have to go to dig into maybe your Git repos if you are using GitOps to deploy and stuff like that, and start comparing manually to see what are the diffs, etc. Here, it seems like Davis is doing that sort of comparing for you and hands off some hints about what could be the issue. So that's really cool. And so my other question, I'm waiting for questions in the channels, but since I don't see any comment, I'm asking my own ones, and hopefully they will be useful for the audience as well. And so, is Dynatrace able to provide some hints about things like, oh, you forgot to define CPU requests limits, etc., for this workload? Is it able to say, okay, maybe you should try this or that? Do you have that kind of approach?
No, we at the moment we don't do that. It's not something that we're looking at the moment. We're more trying to take into consideration all the objects and components and the impact of those components in a given situation. So we are mainly focusing at the moment on increase the value that we provide when we're observing Kubernetes clusters. We have not yet touched this use case of helping the users to tune up their workload definitions. So this is not yet there. I know that there is a partners of Dynatrace called Akamas. So Akamas, they come from the performance engineering world. They were doing auto tuning. When you do performance
Yeah.
engineering activity, you want to tune, and to do that, you do a load test. You look at the results, and then you make some change. They have an AI engine that do it automatically for you. So in 8 hours, they're able to increase 225% of performance or cost reductions based on with the AI. But now they introduce a new feature where they do live tuning of your cluster. So they take synthetic tests, they run, and then based on those results, they make a decision to make a change. So they don't do a change directly, because maybe people will be concerned about it. They will make a commit in your repo, and then of course if you approve it, then it will be committed, and then if you have a GitOps, it will be deployed process, you will be deployed automatically on a cluster, and then you will be able to see the advantage that of the recommendation provided by this AI engine provided by Akamas.
All right. Okay. Cool. Then thanks a lot. Final question. So we've seen a lot of capabilities around using the tool to monitor actively the workloads. You as a person using the dashboards, etc. But how can you plug that into like a DevSecOps pipeline to basically try to identify some of those issues earlier during like the staging and other phases before actually getting into production environments?
So it's an excellent question. So Dynatrace has a couple of open source initiatives that we have launched over the years. There's one called Captain. So Captain has now a change. So we have the version 1 and the version 2. The version 2 is called Captain Live Workload Lifecycle, and the first one was like a platform that was doing either CI/CD or just remediation or just quality gate. And here, what I want to emphasize is the quality gate. So we have a component. So it's an open source solution, but we also have a module that Dynatrace provide called Cloud Automation, where you can do all those automation in Dynatrace automatically, and all those components were coming from a managed version of Captain, I would say. And one of the components called the quality gate. And the quality gate, the notion is that you may want to evaluate a dev test or a dev release and be able to promote your release from a dev tenant to dev cluster to a staging, and then if staging goes well, you wanted to make it a release candidate to production, and do that automatically, and that Captain can do that. So they have this component of quality gate where you define your SLI, you define your SLO. So my SLO or my SLI, my indicator could be in Dynatrace. So it could be in a dashboard, or it could be we have also a metric expression query, so a way of querying a specific metric. Or it could be in Prometheus, so we can do a PromQL. And basically, you define your SLI, you define your SLO, and you can have maybe 10 to 15 SLO covering the availability, the network, the security, different requirement that you cover from the various SLOs with different weight. And at the end, every SLO will give you points, and you will be able to say, okay, so if I have a score in dev environment out of 90%, 90 out of 100, then yes, automatically deploy to staging. So then you can think of lots of automated process where you deploy, you run some checks, and you can go further. With the new version, Captain Lifecycle, we are basically part of the cluster. We changed Captain to make it easier to deploy and easier to configure. So we are part of the scheduler of the Kubernetes. Every time you deploy, we do pre-deployment checks, and then we deploy, and then we do post-deployment checks. And those deployment checks is very flexible. You can do jobs, you can do TypeScripts. There's plenty of things you can do. So, for example, if I'm deploying my service and it relies on my database, if the database is not there, then obviously my service will start. But because the database is not there, I will probably have a crash to backup, an error. It will try to restart to reach out the database. Basically, we can do pre-deployment checks where we say, oh, so this is a dependency of the database. Oh, wait, so pre-deployment checks, is the database here? Yes, it is. Okay, so we can deploy. So the Captain lifecycle now is pretty much designed to make your life easier in Kubernetes. And the great thing is, because we are part of a scheduler, then you can use GitLab, you can use Jenkins, you can use any CI system of the market. From the moment you've been basically deployed in Kubernetes, then we do these checks before and after, and it makes your life easier to manage a deployment in Kubernetes.
Very nice. And you know what? Actually, this is, I have a special interest for DevSecOps. And I think if you're okay with that, we will want to invite you again for another session, maybe you or a colleague that works on that topic, to speak more in details about this specific topic, because it's at the core of, when you are trying to automate your CI/CD or DevSecOps pipelines. You need to have that automated capability to decide if you are moving further or if you are stopping, those security or quality gates and performance gates in our case. So yeah, I think it would be really good to have a session about that specific topic.
Oh, that'd be great. With pleasure.
All right. So thanks so much, Henrik. We are just a bit over time. So if there are no further questions, I will again thank you very much for your session. It was very valuable, and I hope our users are gonna like it as well. Again, if you are not already subscribed, please like and subscribe, and keep in mind that there are other sessions on the OpenShift TV. You have the links to Henrik's channel as well. If you want to subscribe, feel free to go there and check his awesome content. And thanks so much for joining us today, and see you soon. Thank you, guys. Bye-bye.